7274. During a wing stall, the wing tips of a weight-shift aircraft are A. Ineffective for stall recovery. B. Effective for stall recovery. C. Effective only when combined with maximum engine output. The correct answer is B. During a wing stall, the wing tips of a weight-shift aircraft are effective for stall recovery. In weight-shift aircraft, such as hang gliders or trikes, stall recovery techniques differ from those of traditional three-axis aircraft. Weight-shift aircraft rely on shifting the pilot's weight or using control bars connected to the wing to control the aircraft's attitude and maneuverability. During a wing stall, the wing tips of a weight-shift aircraft play a crucial role in stall recovery. As the wing approaches a stall, the wing tips tend to rise or lift higher than the rest of the wing. This can lead to a loss of lift and a destabilized condition. To recover from a stall, the pilot can take advantage of the wing tips' effectiveness. By shifting their weight or manipulating the control bars, the pilot can lower the wing tips and increase the angle of attack of the wing. This helps to restore lift and regain control over the aircraft. Therefore, the correct answer is effective for stall recovery. 7275. The cross tube is positioned by A. A quick-release pin. B. Self-locking bolts. C. Restraining cables attached to the rear of the keel. The correct answer is C. The cross tube in a weight-shift aircraft is positioned by restraining cables attached to the rear of the keel. The cross tube is a structural component that connects the main keel of the weight-shift aircraft to the wing assembly. It provides stability and support to the wings. Proper positioning and alignment of the cross tube are important for the overall structural integrity and flight characteristics of the aircraft. To ensure the correct positioning of the cross tube, restraining cables are attached to the rear of the keel. These cables are responsible for holding the cross tube in place and preventing it from moving or shifting during flight. By properly tensioning and securing these restraining cables, the cross tube remains in its designated position. Therefore, the correct answer is restraining cables attached to the rear of the keel. 7276. On some trikes, the hang point is part of A. A variable trim arrangement that allows the pilot to adjust the aircraft's center of gravity during flight to obtain the most favorable aircraft performance. B. An adjustable trim arrangement that allows the pilot to adjust the aircraft's center of gravity during flight to obtain the most favorable aircraft performance. C. An adjustable trim arrangement that allows the center of gravity to shift fore and aft along the wing's keel. The correct answer is C. On some trikes, the hang point is part of an adjustable trim arrangement that allows the center of gravity to shift fore and aft along the wing's keel. The hang point is the attachment point where the wing is connected to the trike structure. In weight-shift aircraft like trikes, adjusting the position of the hang point can have an impact on the aircraft's performance and handling characteristics. By shifting the hang point, the center of gravity, CG, of the aircraft can be adjusted. An adjustable trim arrangement allows the pilot to change the position of the hang point, thereby shifting the CG forward or aft along the wing's keel. This adjustment can affect the stability, maneuverability, and overall performance of the trike. By finding the most favorable CG position, the pilot can optimize the aircraft's performance based on the flight conditions and personal preferences. Therefore, the correct answer is an adjustable trim arrangement that allows the center of gravity to shift fore and aft along the wing's keel. 7277. The keel pocket's purpose is to A. Act as a longitudinal stabilizer, keeping the wing from wandering left and right. B. Act as a roll stabilizer, keeping the wing from wandering left and right. C. Act as a yaw stabilizer, keeping the wing from wandering left and right. The correct answer is C. The keel pocket's purpose is to act as a yaw stabilizer, keeping the wing from wandering left and right. In weight-shift aircraft, such as trikes, the keel pocket is a structural element located on the keel which is the central tube connecting the wing and the carriage. The keel pocket serves to stabilize the aircraft in the yaw axis, which is the left-to-right movement around the vertical axis. During flight, various factors like wind gusts or pilot input can induce yawing movements in the aircraft. The keel pocket helps counteract these yawing motions and provide stability by resisting lateral movement and keeping the wing from wandering left and right. It helps maintain the desired heading and prevents excessive yaw oscillations. Therefore, the correct answer is act as a yaw stabilizer, keeping the wing from wandering left and right. 7278. How does the wing design feature, washout, affect the production of lift? A. The wing tips continue producing lift when the main body of the wing is not producing lift. B. The main body of the wing continues to produce lift when the wing tips are not producing lift. C. The center of lift moves from the trailing edge of the wing to the leading edge of the wing as the wing begins to stall. The correct answer is A. The wing design feature, washout, affects the production of lift by allowing the wing tips to continue producing lift when the main body of the wing is not producing lift. Washout is a technique used in wing design where the angle of incidence, the angle between the wing's chord line and the longitudinal axis of the aircraft, decreases from the root of the wing towards the wingtips. This means that the wingtips have a lower angle of incidence compared to the root section of the wing. During flight, as the angle of attack of the wing increases, there is a point where the wing will begin to stall, meaning that the smooth flow of air over the wing is disrupted and lift is significantly reduced. In a wing with washout, the wingtips, having a lower angle of incidence, will stall later than the main body of the wing. This allows the wing tips to continue producing lift even when the main body of the wing is stalled. By maintaining lift at the wingtips, washout helps to maintain aileron effectiveness and control authority during the stall. It also contributes to a more gradual and predictable stall behavior, providing pilots with increased warning and control during stall conditions. Therefore, the correct answer is the wing tips continue producing lift when the main body of the wing is not producing lift.